Here I have a class called point. And actually, this class is going to show up over and over again this week in different forms every time. Sometimes the members will be private, sometimes they won't. It's going to show up in a bunch of unrelated examples. In this version, I use it to represent a point in the plane, so it has x and y coordinates. And when I construct the point, I give the x and y coordinates, and after that, they're permanent. The point is immutable. It can never be changed. If you want to change it, then just make a new one. Make a new point. So if I wanted to change the y coordinate to 17, I would just make a new point that's 6 and 17. Okay, so there's actually a lot of reasons why this is a valid design technique, and it'll actually help us in this example in ways that won't be obvious until later. But we'll see a few other point classes this week. So in any case, if I want to retrieve the coordinates, I can do that here, but because of encapsulation, it's impossible for anybody on the outside to modify the x and y coordinates once the class is created. Okay, great. So a nice way to celebrate learning how to write my own classes like we did last week. And to celebrate the week before last, I want to take a bunch of point objects that I've just created myself and put them in an STD set. I want to make a big collection of point objects as a set that I can then search quickly. So I create my point set of element type point. And then I use .insert to add my points to it. I just obviously am so excited about this that I don't read this comment. And then I print out the contents of the set. And then I use .contains to perform the defining operation of sets, this fast searching that we saw a couple of weeks ago. I try and search for a couple of different points. Okay, great. This is so much fun. I'm learning so much C++. I'm so excited. I press enter on the compile command. Oh, and then the compiler throws a huge tantrum. Okay, so what's happening here? Well, we scroll the way up. Poor compiler. And then we find the first red, there it is, and it says no match for operator less than. Okay, and then we see there's point showing up a couple of times, which is a sign that it might be sort of our fault. So what happened? Well, the issue is actually one of the other defining characteristics of sets. The set wants to maintain its elements in a particular order, in the ascending order of the element type. It wants to store the elements in sorted order. How does it sort them? Well, it sorts them by asking questions like this. So here's one point. Is this point less than this one? Well, wait a minute. Have I given it any indication of how that question gets answered? The compiler doesn't do this for me. If I make up my own type, the compiler has no idea what it means for one object to be less than another. That's my job. And the way the set litigates that is it just uses the less than operator. It assumes if you want to put a type into a set, you will make sure that that type has a less than comparison operator. Recall that the less than operator takes two operands, the thing on the left and the thing on the right. Maybe we'll call them P1 and P2. And the less than operator answers a yes or no question. Yes or no, is P1 less than P2? That's all we want to answer. Just yes or no, true or false. Without that, the set can't do anything. Now, interestingly, the set doesn't actually need less than or equal to or greater than or anything because it's able to use less than for everything it needs. So as a convenience to you, the set only needs a less than operator, but it does need that. So if we want to add our own type to a set, we have to define the less than operation. We have to define our own less than operator. And recall from the previous video that if you want to define an operator, like the one I'm describing, which takes two operands and returns a true or false value, all you really need is to be able to define a function with those characteristics. So I suppose, as an exercise, I could try defining a function. Point less than point. What does it take as its arguments? Well, it takes a point P1 and a point P2. Okay, and then it asks the question, is P1 less than P2? And it returns a bool, true or false, based on whether P1 is less than P2. Okay, so what does it mean for a point to be less than another point? Well, actually, that's my call. I could make up whatever definition I wanted. As long as it's consistent, I can use whatever I want. I'm going to use, I think, a pretty rational one. So I have 2 points. I'm going to compare their x coordinates. So I'm going to say, is the x coordinate of P1 less than the x coordinate of P2? If the answer is yes, then P1 is less than P2. So in this case, 5, 100 is less than 6, 10. In the case where they're tied, so 6, 10 and 6, 17, well, in that case, we'll compare their y-coordinates. So if the x-coordinates are equal, then I will compare the y-coordinates. And if the y-coordinate of P1 is less than the y-coordinate of P2, then P1 is less than P2. In all other cases, so if the x-coordinate is greater in P1, or if the x-coordinates are tied but the y-coordinate is greater, or in the case where I've got two of the same point, so 6, 10 is not less than 6, 10. In all those cases, P1 is not less than P2. So I'll try and write those comparisons. So I'll say if p1.getx, so I'm not allowed to use x directly, I have to use getx. If p1.getx is less than p2.getx, then that would be the case we have up top here, where the x-coordinate is less. In that case, p1 is less, so I return true. p1 is less than p2. In the alternative case, where the x-coordinates are tied, so p1.getx is equal to p2.getx, I should observe here, I'm using the less than and equal to operators on the x-coordinates because they're just doubles. So getx returns a double. Of course, I'm allowed to compare two doubles together. If p1.getx is equal to p2.getx, that would be this case down here, then I just compare the y-coordinates. Then I say, well, if p1.gety is less than p2.gety, then I guess P1 is less than P2, so I return true. In all other cases where the points are either equal or where P2 is greater, well, in those cases, P1 is not less than P2, so I return false. Okay, I've written a function to compare 2 points using the logic I just came up with. Keeping in mind, I could come up with some other way of ordering them and that would also work as long as I'm consistent. It's my call. I'm the inventor of the point object. For example, I could consider y-coordinates first. That's fine, as long as I'm consistent, but I'm going to do this one. So I've written a function that takes 2 points and returns a bool. And what I want is for this to be the less than operator. When I ask the question, is P1 less than P2, I want this to get run. So instead of a function, I'm defining operator less than. There we go. We'll see if the compiler has recovered and whether it wants to give that another try. And there it is. And we'll try running it. And we'll notice I add the points in no particular order. And when I iterate over them, I get -3, 5, then 1, 3, then 6, 10, then 6, 17. They're all in order according to the order I defined. I go searching. I look for the point 6, 10, and I find it. Well, that's because it's there. I look for the point 1, 11, 1, 16, and it's not there. So searching also works. I defined my own less than operator, which is the natural way. If I want to compare 2 points, it makes sense to use the less than operator. I define my own, and now I can define an STD set containing my type. I can also define an STD map where the key is of my type. Both set and map require the key type to have a less than operator. And so there are cases where not only is operator overloading convenient, as we saw in the previous video, but there are cases where you have to use it because to get the functionality you want, the common language we're all speaking here, so in C++ between us and the standard library, if I want to compare something, I use a comparison operator. So that means if I want my type to be comparable, I need to define my own less than operator for it. There are a couple of ways to get around that if you want to do a special type of comparison, but in general, this is the standard idea. If there's a natural way to compare your object, define yourself a less than operator.